Alright, hi y'all. So we're just gonna talk about some more Python today. I just wanted to go ahead and get started with you guys and show you some interesting things. So today we're going to talk about flow control, and flow control is basically just how a computer or a program makes decisions. So we're just going to talk about that today. So the best way to think about this is if you have a program that needs to make a decision, how are we going to get to a certain point? So imagine, for instance, you are, waking up. You wake up in the morning and you look outside to see what the weather is, and then you're going to change your actions based upon your weather, right? So the biggest thing that might happen is it might be raining, right? So if it's raining, you're going to bring an umbrella, or you're going to just wear a raincoat, or if maybe it's really sunny, you're going to put on sunscreen. So basically that's how flow control works. You have these if-then statements that are being asked, and if you're doing a certain thing, then we're going to do something else. So if it's raining, I'm going to wear a raincoat, or I'm going to bring my umbrella. If it's really sunny, I'm going to put on sunscreen. So that's really a simple way to explain it. When we're actually doing this in practice in Python, we use something called a Boolean value. So we were talking about those data types the other day, the ones that were like integers, strings, and so on. This is another one of those data types, except this data type kind of talks about if something is or isn't true or false. So these are called Booleans. So Booleans, spelled like this. Let me go ahead and make a new file here. Boolean, spelled like that, is named after a mathematician named George Boole, and that's why it's always capitalized, because it's named after somebody. So the way these work is, we talked about variables last week. So let's say we have a variable called live, because I'm streaming live right now. So we're going to say if live, we're going to just declare this variable as true. Just like that. So now our variable is set to true. If we were to say something like print live and then run it, let's give it a second to boot up here. It's probably going to ask me to save. Yep, okay, so let's go ahead and give it a save here. Boolean.py. Alright, we'll save that. And now we see our output down here, which says true. So we're basically just saving our Boolean into a value and then printing it out. Simple, easy as that. So a way that this might work is if I were to say something like if live equals true, then we're going to do something. So I'm going to put something inside of this code, or this section over here, and have something happen. So what we're going to do is just say if true, if live is true, colon, because we have to have that colon start our statement, then we're going to print the word yes. I close that out, and when I click run, or stop, and then run it, you'll see it now prints true and yes, because I still have this print statement up here. So let me just walk through a couple of the things I just did there. So you can see that I used an if statement, which is, we'll talk about that in a second, but the most important thing I want you to notice were these two equal signs that I used. When you're making a comparison of Booleans, or just a comparison of really anything, if you're comparing two strings or you're comparing two numbers, you always have to use these double equals. So the double equals basically just checks to see if something is equal to. There are a few other options you can use. You can also use exclamation point equal. An exclamation point equal basically means it does not equal something. So if I was to say if live does not equal true, the code that was inside of this would only run if live wasn't true. So this will actually never run because live is hard-coded to true. There are 4 other main ones that you can use here. So if we were to be comparing numbers, say we wanted to do like 4 and 5, we wanted to compare those numbers, we would use the less than symbol. So 4 is less than 5, and if that is true, then we'll do something. Or we can also use greater than, like that. So if we were to say 4 is greater than 5, and we were to say if 4 is greater than 5, 4 will never be greater than 5, so our code will not run. Whatever we put inside of that if block will not run. You can also use the modifier of less than equals, which basically just says if it's less than or equal to, so if it's something like 5 is less than or equal to 5, that will run because 5 equals 5, and also 4 is less than 5, so the code would still run. You can switch that around and make it greater than. Obviously this code would not run, but this code would run. So there are a couple of different comparisons you can do. So let me just show you really quick some examples of these. So if I were to say 42 equals 42 and then click run, nothing's going to happen, right? Let's do this. Let's say that we want to print, and let's see if this will work for us here. There it goes. So you can see it's printing true. If I were to put another number in here, like 21, which we know is not equal to 42, and hit run, it would evaluate to false, and that's printed out. So let me just show you a couple other ones of these. So like I was saying, that less than will print out. That's true, obviously, but if I were to change this to like 52, or you know what, let's do this. Let's change it to 42. 42 is less than 42. When we do that, it's going to evaluate to false because 42 is not less than 42. But if we say 42 is less than or equal to 42 and run it, we get true. So there's just a couple of different things here. If I were to even say does not equal, we know that that should evaluate to false because 42 does equal 42. So you can use these different kinds of things with these operators with strings as well. So if I wanted to compare the string hello to hello like this, I could do that, and now I would just hit step and run it, and you'll see that these are equal. But if I were to go in here and change that to 1 uppercase and run it, it's false. That's because this is a different string than this. Even though they say the same thing, they're different because one is capitalized and one is not. So you can use comparisons like that. I can even say like does not equal, and now it'll run and it'll evaluate to true because those two are not the same thing. Be aware that when you are using the less than or less than equal to or greater than equal to, those only work with integer or floating point values. I'll give you an example. If I were to try to run this using a less than, we're going to get an error when I try to do this. So, oh, it does evaluate to false. Well, it evaluates, but it doesn't really work. So we don't want to do that. We only want to use equals and does not equal when we're making the comparisons. So let me just dive back into this idea of double equals versus equals, right? So the reason we have these two different things is because a double equals is to make comparisons, while a regular equals is to assign something. So you know how we were talking about variables the other day, or even today, and we said live equals true. We only use a single equal sign there because we're assigning this variable to be true. If we were trying to make a comparison to see if live equals true, we would use double equals. So that's kind of why you do that. It's just really easy for us to do. You can also use these little statements called and or. They're like they're binary Boolean operators, which I know is a lot. We don't really need to go in depth about what that means. You basically just need to know if you use them, you just use the words and or. So I would say something like true and true, and when we run that, it's going to evaluate to true, right? Because both of these are true. But if I ran them as true and false, you'll see we get false. That's because when you use an AND operator just like this, they both have to be true for the statement to be true. You can throw in a false here, and you see you still get false. The only way for an AND statement to evaluate to true, in this case, is to put true and true. Like I was saying earlier though, there's also the OR operator. So if we wanted to use OR, we could do true and false, or sorry, true or false, and it'll evaluate the true. If we did false or false, it's still going to be false because it doesn't really get a choice. And then we can do false or true, and it's going to evaluate as true. That's basically because it's saying if one of these is true, then the whole statement is true. Like I said, these are kind of simple. I know I'm running through these. We're not really going to talk about these very much right now. And the reason we're not going to is because it's not super important at this juncture. But we have a false or true. We can also use not false or not true. We just add these nots. So that switches this not false to a true, and this not true to a false. So we're still going to evaluate as true because it ends up having one true. And we'll talk more about the not when we get to some actual meteor things that we're doing here. So let's talk about blocks, blocks of code. So I know I showed you that if statement earlier. Let's talk about the basic parts of an if statement. So if we were going to do a block of code, for instance, in this case, it's just a group of code. In this case, we're doing if statements. So we're going to say if, and then we always have to have these opening parentheses around our comparison. So we can make our comparison of, I don't know, 1 is less than 5. And then we close it up, and we always have to put a colon. The colon lets it know that this is a conditional. This is where we're making the condition. And you can see that when I just pressed enter, it automatically tabbed over and added this white space for me because it just wants us to stay neat, and that's great. It makes things much easier to read this way. So now inside of it, like I said, I can just print yes, and when I click run, it's going to print yes because 1 is always less than 5. So that's a really simple way to do this. So a better example of this would be to do something like, let's set a variable, and we'll set a variable with my name in it, and we'll set a password, and I'm just going to set this password equal to Imagicode, because that's something I can remember. And what we're going to do is we're going to say if, and I'm going to go and put these in the parentheses just to be safe, name equals, and I'm going to say Justin, nope, can't forget that colon, and then I'm going to say if password equals Imagicode. Make sure I do lowercase, otherwise the code will not run. Colon, and now I'm going to print the words access granted, but only if the password is at. If it's not, then I'm going to do something completely different. So when I run this code now, you should see it prints out access granted. So that means that our statement is working. You can see here that I have what this is called nesting. I have nested one if statement inside of another, so that basically this and this both have to be true. We can condense this down a little bit more, but we'll talk about that later. It's not really important right now. I like the way this looks a lot better than if we were to, put them all together. If I go ahead in here and just change that uppercase to a lowercase there and try to run it, we're not going to get anything because now my name, Justin, with an uppercase, does not equal my condition, Justin, with a lowercase. So that's why that isn't working. So we're really using, I'm showing you off this if statement first, and it's basically just making a check to see if something is happening, then we're doing something. But what happens if we want something to happen when this is not true? Well, there's a couple different ways we can do it, but the easiest way to do it is just to do an else statement. So I can type out the word else and then say print access denied. So that now, if, say, I got the passcode wrong, say I did a capital I here, it's going to read out and say access denied to me. But here's the thing. If I do it this way, and I don't put my if there, if I don't put an else attached to this if, nothing's going to print. That's because this else only runs if we get past this point. So because my name does not equal Justin with a lowercase, we never actually get to this if statement, and we never actually get to run any of this code. So let me just change that back really quickly. So an easy way to show this off, we'll just delete all this. We'll do a little bit of examples here. We'll do a couple examples. So I'm just going to once again say if name equals, and I'll make it my name. You can make it your name if you'd like. And then we're going to say print, and I'm just going to have it say hi Justin with an exclamation point, and I'm going to attach an else to this. So now I'm attaching my else to this if. Make sure you have that colon there, and if it doesn't know me, then I'm going to have it say hello stranger. Just like that. So I'm going to stop, I'm going to run it, and it says hi Justin, and let me just go ahead and change this so that now it doesn't equal, and you can see it says hello stranger. So that's an easy way to control the flow of your program. That's why this is called control flow, or flow control. So you can see it's now making a decision based upon what this variable equals, if it should tell me hello as my name, or it should be more formal and say hello stranger. So it's just kind of an easy way to think of it that way. But there's also other ways to do this. So there's another statement I can add onto this. So let's say that we have name, I'm going to change that back to a capital. Let's say that we want to be able to check multiple names against this, right? We want to be able to see if maybe someone else's name. So let's do elif. So this is a new type of statement we haven't really seen yet. And this elif just stands for else if. So we can say else if name equals, I'm just going to say Adam. Then we're going to print hi Adam. Alright. So there we go. So we're just going to go and check to see if something says hi Adam, or if my name is Adam. So we're looking here, and sorry, just looking real quick. We're looking here, and we'll see that if the name equals Adam, then I'm going to try to run it. It says Justin because it's still set to Justin up here. I'm going to change it back to Adam, and I'm going to click run, and now you can see that it's checking to see if it's Adam, and if it is, then it's saying hi Adam, and I'm going to make this lowercase because we still have that else at the bottom there, and since neither name, Justin or Adam, is equal to lowercase Adam, it prints out hello stranger. So we now have three different choices that it can make between these three if, else if, and if statements. So as that's going, that's pretty helpful. We can do a couple other things. You can even say, like, maybe you want to check to see if it's Justin, and then nest a if statement inside of that if you're 12, if you're 13, checking things like that. So that's pretty helpful. So now we're going to move on, and I'm going to talk about something that's a little different. So in this case, we're going to talk about the word, the new concept, a while statement. So a while statement is basically just a way to make things happen over and over and over again. So it'll never stop. So let's say, let's write a simple spam program here. So let's say that we wanted to spam somebody with a message. So let's say spam equals 0, and we're going to say if spam is less than 0, then we're going to print the statement hello world, just like that. And then let's go ahead and make it so that we're going to increment, and I'm just going to use that little operator that we learned about last time, the plus equals 1, so that we're adding a number to it and saving it back in spam. And now let's hit run and see what happens. So, oh, that's why. Nothing happened there because I typed a 0 instead of a 5. There we go. So when we type a 5 and it's less than, so 0 is less than 5, we're going to print it. But you can see that nothing else is really happening. This only happens one time. So if we wanted this to happen multiple times, say we wanted it to happen 5 times, we can change this if to the word while. So now we're just checking to see if spam is less than 5, and if it is, we're printing, and then we're adding 1 to spam, and then we're coming back up here to check to see if spam is still less than 5. And at this point, after we've added 1 to it, it'll be 2. So 2 is, well, it'll be 1. So 1 will still be less than 5, so we'll print it again. Then we'll add 1, then we'll come back, and it'll say 2 is less than 5. And we'll print again, and then we'll add 1, and then this 3 is less than 5, and then so on. So let me just click it and give you a run example of that. So you can see it printed out 1, 2, 3, 4, 5 times. So while spam is less than 5, we're going to print it, we're going to add 1, and then we're going to go back. And when we finally finish that process, it's going to exit that loop. That is called a while loop. So that is a good way to kind of have your code do something over and over and over again. So if you wanted to say, like in this example, spam somebody a lot, so I can do something like that. And you'll see it's now spamming the bottom for 1,000. It ran pretty quick because Python's a quick coding language, and this is a really simple program. But you could theoretically make a spam program that would keep going these things forever. So let's use this to do a little trolling, for instance. So let's say we have something like let's set up a variable called name, and we're just going to set it to a blank. So there's nothing in there, right? So just nothing is saved inside of that. So then I'm going to say while name does not equal your name, and I gotta remember to put all this in parentheses really quick. We're going to ask them to type their name. So we're going to say, please type your name, right? So I don't know if you can see kind of where this is going, but we'll talk about it in a second. So if you kind of figured it out already, that's great. If you haven't, that's okay too. So I'm just going to now save our input into name. And then I'm just going to have this statement down here that says, thank you. And you can see that I put this print statement down here and it's not indented over. That's because this print statement will only run once we leave this loop. So let's go ahead and try it out. So it's going to ask me to type my name. I'm going to type Justin. Okay, it's still asking me to type my name. Maybe it wants Adam. Okay, maybe it wants it lowercase. All right, I'm running out of names here. Or what about Bob? Okay, none of these names are working. So the trick here is it's literally asking us to type your name. So when I type the string your name, it says, oh, name has been set to the string your name, which means that name is finally equal to your name, so that we can leave this loop and tell them thank you. So it's kind of just a trick. It's one of those things where you're just being asked to type literally what it says. So you can try whatever you want there. It's not going to work until you type your name. Now, there's another way you could do this if you wanted to. Say you wanted a shortcut, if you wanted to just to break out of your file here. You could use or your loop. You could use something called a break statement. but that's not super important. Another way you could do it, so I'll just give you the example just so you can kind of see. You could just say while true, so this loop will literally run forever unless you were to go in here and add another if statement that says like that, and then type the word break. And if you did this, it would still work the exact same way. It's just a little more literal to read, and it will break out of your loop here instead of having to go back up here and do the check again. Instead of jumping back to the top to do the check, it'll just say, oh, we're making the check here. Don't have to check. We're breaking out. We're good to go. So that's just another way you can do it. And these will be basically infinite loops. So the next thing we're going to talk about is we are going to go ahead and talk about let's see, where do we want to go here? You know what, actually, let's just go ahead and write our first program. We're going to use a couple new things I haven't talked about yet, but I'll walk you through them as we go. We're going to go ahead and just make a simple rock, paper, scissors game, right? So everyone knows how to play rock, paper, scissors. So let's go ahead and get it. Let's go ahead and get this. So the first thing we're going to do is something we haven't done before, which is just use what's called an import statement. So an import statement, for the purpose of this lesson, is basically just going to look at the files that come with Python. So when you install Python, it comes with a bunch of different packages and files and things that we can use. So we're going to use a couple of them. We're going to use one called random, and random is exactly what you think it is. It just picks random numbers or random whatever from things that you might want to be able to use. And then we're going to use sys. So sys is just system, short for system, and it will allow us to do some other interesting things here. So let's go ahead and get started. So let's go ahead and print the name of the game. I'm just going to print it out in all caps because I think it looks cool. So we're going to say rock, paper, scissors, and so it's going to print the name of our game every time at the very beginning of our game. Then we need to set up some variables, right? We need to check, we need to set some variables to keep track of our wins, our losses, and our ties. So I'm just going to set up 3 different variables. I'm going to make sure I turn that caps lock off. So I'm going to do wins equals 0 because both you and the computer start at 0, or you and the player you're playing against start at 0. We're going to set losses to 0, and finally we'll set ties to 0. So you can see here now we have our, just give me 1 second. Yes, you do have to do double equals, Bennett. You, when you're making a comparison, you always want to do double equals. So let me just get back to this really quickly. So with the ties now, we've set up our 3 variables that we want to use here. So let's go ahead and set up an infinite loop so that our game will run, basically, as long as we need it to. So I'm going to say while true, and like I said, that's an infinite loop. The only way we could get out of this is if we somehow change this true value to false, which we can't because it's not being saved in a variable. The only way then we can get out of it is by using that break statement or a sys.exit statement, which we'll talk about when we get to that point, to get out of that loop. So the first thing we're going to do is we are going to say print, and we're just going to use the % symbol. And we're going to say wins, % losses, and % ties, just like that. So the reason we're doing this and the reason we're using these percent is because you can use this to assign our variables or assign what's going to pop up there at those percent symbols a lot easier than if you were to do it a different way. If you were to, do the long way of concatenating our strings. So let me just finish up and I'll show you what I'm talking about here. So then if you look there, you'll see that we have our closing quotation mark there. We'll just space over and we'll type this percent symbol again, right? And then we're going to say wins, losses, ties. And that's basically now just saying, okay, every time we see this, the first time we see this, it's going to be replaced with our number of wins. The second time we see this, it's going to be replaced with our number of losses. And the third time we see this, is going to be replaced with our number of ties. So now we need to make sure that we put one more parentheses, because like I said, every parentheses needs to have a pair. And now we have our pair. So I know that was a lot, so if you're having some trouble kind of walking through that or figuring it out, basically this is just a way to always display how many wins, losses, and ties we have before we're asked to make our move. So like I said, this percent can just be thought of as a way to not have to type out a really long version of this, which would be something like this. So the other option would be to write it out and say wins plus S or just wins and then close it and then do another one, losses. So you can see that's way longer and going to take up way more time. This is just way more compact. And like I said, this is just a kind of an operator to make things easier on us. So we're just going to do it that way. So now, once we've done that, we're going to once again enter another loop because we have our actual game starting. This is the player input loop. So let me just add a couple comments here so that we can kind of see where we're going. So this first one would be called the main game loop, and the second one down here would be called player input loop. All right, there we go. So now we're just going to go inside of this next loop and we're going to ask our player to input what move they want to make. So we're just going to say enter your move, just like that, and I'm going to put a colon, and we're going to make it simple so that they don't always have to type out rock, paper, or scissors all the way. We'll just have it so that they can type out just the first letter. So we'll say rock, paper, scissors, or we'll let them quit the game if that is their choice. So now we're asking them to enter their move, whatever they would like to do. If they want to click rock, paper, scissors, or quit, all they have to do is type in the letter they want. So then, if you remember, we have to do something to get that input. So to get that input, what we're basically going to do is we are going to ask for the input and save it in a variable. And let me just go back up here to this for a quick second. I had a good question from Bennett. The reason I'm doing spaces between these after these commas is because when it prints out, it's going to look prettier this way than if I were to do this, because then there won't be a space in our string. But with this, you don't really have to. I mean, it is probably nicer for you to do this, so I'll just go ahead and do it. It just makes it easier to read when you add these spaces. This won't be printed out, so it'll never actually say wins, lost, ties like this. It'll only print out what is in between these quotation marks here. So that's the reason why I had the spaces there and didn't have them there, but either way it works. So now what I'm going to do is I'm just going to save our input into a variable called player move, and I'm going to say player move equals input, and that's just going to grab the input of whatever the player says. So it's going to wait on us to give our input, and then it's going to do something. So let's let's run this and see if it works right now. So if you look here, it says rock, paper, scissors. It prints out our wins, our losses, and our ties, and then it tells us to enter our move. So it's going to let us do that, right? It's going to let us put in whatever kind of moves we want, and obviously nothing's going to happen because we haven't said what to do with those inputs yet. So that's fine, that's great. Everything seems to be working at this point. So the next thing we're going to do then is tell what to do if the player wants to quit the game. So if the player types in Q, let's go ahead and see if the player move equals, and we'll just have it check to see if it's Q. If it is, then we're going to use that sys import that I talked about earlier, that sys.exit. So we're going to say sys.exit like that, and I'm just going to give you an example of kind of how this works. But basically, it's just going to quit the program. So I'm going to put a note here, a little comment for myself so I know what that does. So if I were to run it and then click Q, you'll see that it says traceback line, quit the program, sys.exit, and it has now stopped our program. So that is kind of how that works. So let's go ahead and click stop here, and we will keep going. So now let's do what happens if the player is setting their choice to R, P, or S, so rock, paper, or scissors, right? So they're finally making their choice, then they're going to move outside of the input loop and then move into the simulation part of it. So what we're going to do now is check to see if player move equals R, or player move equals P, or player move equals S. And the reason we're doing it this way is because it's just a lot cleaner to write all of this out in one line, because now it's checking to see if player move equals R, if it equals P, or if it equals S. So if any of these are true, then we're going to break out of this loop. So we're going to just type break, and I'm going to leave a little comment here to let me know what's happening. So we're breaking out of the player input loop, just like that. So that's just telling us that we're now getting out of that loop, and we are going to go down here. And basically, if we haven't typed one of those letters, say we just put a random letter like A or W or T or whatever, one of the letters that isn't R, P, S, or Q, then we need to prompt the player to actually put something that works for our program. So what we're going to do is just have it print type one of R, P, S, or Q. So basically, if we get down to this point, that means that our player hasn't picked Q, our player hasn't picked R, our player hasn't picked P, and our player hasn't picked S. So that means that they haven't picked any of the things we want them to pick, so we just need to tell them, hey, you need to pick what we asked you to pick, because otherwise the program's not going to work. So now we have that. So we're just going to break out of that loop, right? So, excuse me, sorry about that. We are going to now check to see what we should do if one of these is chosen. Oh, I'm sorry. So let's go ahead and go down here. You can see that I've now lined my if back up with this while. That is because we are no longer inside of that while loop, because if we get to this point, we should have broken out by now. So now I'm just going to check to see if player move equals R, and if it does, then we're going to print the words rock versus ... And this is just to add some suspense and some flavor. You don't have to do the ... or even type out versus, or even type out rock in all capitals if you don't want to. This is completely up to you. This is just the way I'm kind of deciding to format it. So we're going to check to see if player move is equal to R. And then now we're going to use an else if, because there are other options, right? So we're going to check to see if player move equals P. Then we're going to print paper versus ... And finally, we're going to add one more else if to see if player move equals S. So if they chose scissors, then we're going to print scissors versus ... just like that. So now we are checking to see if it's R, P, or S. So let me just run this and give you an example. So now we're going to start the game. You can see here that these are being filled in because our values are still at 0. And now we can type in rock. So I'm just going to type in R, and you'll see it says rock versus, and then it goes back up into the loop because we can't exit it because we're not finished the game yet. It's not making a decision. It's not doing any of these things. So I can pick all these other ones, S, anything like that. I can click Q to end the game, things like that. So you can kind of see how that's working. So we're just going to keep working through this, and now it's time to decide what the computer is going to pick. So this is why we implemented that that random statement earlier. We did the import random up here at the top. That's because we want the computer to randomly pick what it's going to do. So let's go ahead and do that. So now let's go ahead and display. I'm going to add a comment here so we know what's going on. I'm just going to say display what the computer chose. All right, so I'm going to then display what the computer is choosing. So we're going to, if I can, there it goes. And so now we are going to basically pick a random number. So we're going to make the computer pick a random number. So to do that, I'm just going to make a variable called random number, and I'm going to set it equal, and this is where we're going to use a function. So we're going to use a function that is inside of the random package that we imported earlier. So to do that, you have to type out the name of the package, which is random, dot, and then whatever function you want to use from that package. In this case, we want to use the function randint, all lowercase. So that basically just means random integer. And we want to put in parentheses the range of numbers. So between 1 and 3. So we want to pick a number between 1 and 3. So it can pick 1, 2, or 3. And then it will do something with that it will save that into the variable, and then we'll do something with that variable. So, like I said, since we're picking a random number, what we're going to do is we're going to check to see if random number equals 1. And if it does equal 1, then we're going to make the computer move equal to R, because it's going to choose rock, right? And we're just going to have it print the word rock, just like that. Then we're going to do another else if. I'm just going to say elif, and I'm going to check to see if random number equals 2. Alright, and if it equals 2, we're going to set our computer move equal to P, because it's choosing paper. And we'll print out the word paper, just like that. Alright, and finally we'll do one last else if, and we'll check to see if random number equals 3. And if it does, obviously that means that computer move equals S, because they've chosen scissors, and we will print the word scissors, just like that. So now let me go ahead and just run this really quickly, and we'll see kind of how it works. So it's going to ask us to enter our move. I enter rock, and they chose scissors. So the computer chose scissors, so I chose rock versus scissors. In this case, it would be a win, but we haven't gotten to that part of the code yet. So it's just kind of running us through, and I'm showing you step by step how this works. And then if I click P, paper versus paper, that would be a tie. And if I do S, scissors versus paper, that would be another win. Let's see if I can get a loss here. Rock versus paper. There we go. So I would get a loss on that one. So let's keep going here, and we'll actually set up how to do the comparisons to see if we won or lost. So let's go ahead and make another comment here, because in this part of the code, we're going to display and record win, loss, tie. So this is basically just going to tell us if we won, if we lost, or if we tied, and then add that to our variables that we set up at the top. So first thing we're going to do here is let's do ties first, because it's the easiest one to do. So let's do if player move, make sure I put those in parentheses there, player move is equal to computer move. That would mean that we made the same choice, so we both chose rock, or we both chose paper, or we both chose scissors. Then obviously that's a tie. So what we're just going to do is we're going to say print it is a tie, exclamation point, just to spice the game up a little bit. And then we need to make sure that our ties variable is being incremented by 1. So I'm just going to say ties plus equal 1. So now if that happens, then we know ties goes from 0 to 1. So then I'm just going to add another else if, because there are other things that could happen here. So let's just go ahead and do this next else if. There are actually a few of these that we have to do. So I'm just going to show you one by one, and we'll talk about them as we go. So the first one, let's say, is if player move equals, let's do rock first. So if we chose rock and our computer chose, let's say they chose scissors this time. Let's start out the win. So if they chose scissors, that would be a win, right? So what we would do is we would go down here and we would say print, and I'm going to say you win, exclamation point, just like that. Make sure I close that parentheses like always, and then I'm going to wins plus equals 1. So that's just going to add on to our wins. So if we chose rock and the computer chose scissors, that's a win for us. That's great. So let's go ahead and get all the wins out of the way really quickly here. So next, we're going to add another elif, and this time we're going to say player move equals paper. So double equals, make sure we're always doing that. And our computer move is equal to rock. So if we chose paper and the computer chose rock, that's another win for us. So we'll say print you win, exclamation point, make sure to close it, and we'll add plus equals 1. And I'm going to put some spaces there just to make it look a little nicer. And now let's keep going with this. So we'll have one more else if statement that results in a win, and that would be if we chose scissors. So if player move equals scissors and computer move equals paper, then obviously that's a win again for us. So let's go ahead and say print you win, exclamation point, make sure we close it. Finally, we'll do a wins plus equals 1 to make sure we're incrementing that number. And so now we've done the ties and we've done the wins. So the last thing to do here is to just put in the code that will let us do for if we're losing. So let's go ahead and do those 3 else ifs. So these else ifs are going to look a little bit different. The only real difference will be what happens if we get to this point. So let's go ahead and say player move equals R. So rock, we'll start the same way we did earlier, and we'll say and computer move. This time we're doing a loss, right? So we want to make sure that our computer is beating us. So what beats rock? Everyone knows that's paper. So we're just going to put paper right there. So now, if we chose rock and the computer chose paper, oh no, that's not good. That means that we lost. So I'm just going to have it say, you lose. And then we need to make sure that we increment our losses. So I'm going to go ahead and do that with the plus equals 1. And now we have another. Let's go ahead and add another loss for us. So if we were to lose by picking paper this time. So if we chose paper, like that, and our computer chose scissors, once again, that would be a loss for us. So I'm just going to go ahead and repeat what I put earlier with the loss. So I'm going to go ahead and put print, just like this, print, you lose, exclamation point, and we need to increment our losses, so I'm just going to do that, that. And now we're going to do, finally, our last else if. So we're going to go ahead and do our last else if, and this is if we pick scissors and they chose rock. So we'll do player move equals scissors. Make sure you're doing those double equals because we're making comparisons, remember? And computer move equals rock. Alright, there we go. So now again, this is a loss for us, which is not great, but it's okay. We'll say you lose, exclamation point, and finally increment our losses. So I believe this should be the end of our code. Let's give it a run and find out if it's working here. So we have rock, paper, scissors, the title. We have 0 wins, 0 losses, 0 ties because we just started it. And we have our way to enter our move. So let's go ahead and I'm going to pick rock. Alright, looks like we tied. So you can see that the number now is updated. 0 wins, 0 losses, 1 tie. Now, let's go ahead and try it again. Let's do paper. Alright, I lost that one. So now you can see 0 wins, 1 losses, 1 ties. So let me go ahead and I'm going to choose rock again. Maybe that'll trick it. I lost again, so I've got 2 losses. Let's pick scissors. I finally won 1. So you can see this is all updating. 1 wins, 2 losses, 1 ties. I'm going to go ahead and end it there. I'm not feeling too good about my luck tonight, so I'm going to type Q and quit the program there. So now we have our whole program running. Everything seems to be going pretty great here. So that's basically it. That's all I wanted to kind of go over with y'all tonight. I hope everyone had a good night and learned a lot from all this. So if you did, go ahead and give us a like, maybe subscribe, and let us know if there's you have any questions. You can go to our Discord. You can post a comment here. You can go to our website. Any of the options there, or we'll get back to you as soon as we can. So hopefully I'll see you guys next week. It's been great, and I hope you guys take care of yourselves and take care of each other. All right, that's it. Bye.